Hello, welcome back to the LOOC. In this segment we take a second look at methods, a deeper look, and in particular we look at static methods and variables that are associated with classes rather than instances, that is objects. We look at the core return mechanism and how it is supported by the method called stack. We look at how to use a random number generator to implement a game-playing application. We look at the visibility of declarations, also known as scope. We look at how to create overloaded methods, how to use optional and named parameters, how to create and use recursive methods, and we look at passing method arguments by value and by reference. To start with, a comment is that a good way to develop and maintain a large and complex application is to break it down into smaller, simpler pieces and construct the entire application out of the smaller, simpler pieces. This technique is called divide and conquer. Once an application is partitioned into smaller pieces, these pieces are packaged, and they are packaged into these code segments such as properties, methods, classes, and namespaces. The entire .NET environment contains a .NET Framework class library that provides many predefined classes that carry out common tasks, and therefore we don't have to rewrite these classes and the methods within them. There is the MSDN URL where we can look at the .NET Framework class library. So in a browser it looks like that. MSDN stands for Microsoft Developer Network and contains lots of information about the .NET environment. So under the library tab, we can see the .NET Framework class library that consists of many namespaces, each namespace consisting of many classes. There are literally hundreds, if not thousands, of those classes in such a large application framework such as .NET. So it's useful to browse through this huge library to learn it over time. What our class libraries help is code reuse, in particular that when we need to perform a task we don't need to reinvent the wheel. This reduces development time and helps writing well-tested code and good performance of our applications. The purpose of methods and classes ultimately is to modularize or partition an application into tasks that are reusable units. When we write methods that are not part of a class library, but we write it as a custom method, they are also called user-defined methods. And software reusability is one of the main purposes of object-oriented programming, so that we can avoid repeating code. Also, by good modularization and by good partitioning, applications are easier to debug and maintain. Generally, every method should be limited to performing a single well-designed task, and the name of the method should express what that task is. This helps with the development of the application, debugging it, maintaining and modifying it later. If you have difficulties finding a proper concise name for a method, the task it performs, that might be a sign that the method is attempting to do too many things, perform too many diverse tasks. It might be time to break the method up into several smaller pieces. Another rule of thumb is that a method generally shouldn't be much longer than about half a page, at most a single page long. If anything longer than that is an indication that the method is too complex, does too many things, and therefore it's time to break it up. Code that calls a method is the client code, and an analogy of the relationship between methods and their client code is a form of management. So a boss can call on various workers to perform certain tasks. In turn, the workers can also call on further workers to help with that task, and the boss doesn't know how the workers carry out their tasks and is not interested in the details, only in the result. And when a worker calls other workers likewise, it doesn't know what the other workers use as implementation. In other words, how they perform their tasks. They are oblivious to that. They are interested only the proper way of calling and the result that is returned to them. This mechanism of client code not knowing the implementation details is called information hiding and promotes good software engineering practice. An important class of methods and variables is static methods and static variables, respectively. When a method is declared static using the static keyword, that method belongs to the entire class as a whole, and it's not a method that is invoked by individual objects or instances. To declare a method static, the keyword static is used before the return type of the method's declaration, and when we call a static method, we use the name of the class as opposed to an individual object or instance, followed by the member access operation or dot notation operator and the method name. An example is the class math, the math class that is part of the .NET framework class library and has a collection of static mathematical methods. These are operations that perform mathematical calculations so that we don't have right to code for these calculations. An example being square root, that is sqrt, is a static method of the math object, and the arguments we pass in can be constants, variables, or expressions. In this figure and the next, there are a number of examples of math class methods. There are far more than this. These are just some of the most frequently used ones, such as absolute value, ceiling is rounding down, ceiling is rounding up, so the floor is rounding down. There is cosine and similarly sine and tangent as trigonometric functions. The exponential function e to the x in math and the natural logarithm of base e, maximum and minimum to find the smaller and the larger of two numbers, a power function x to the y in math with two arguments. So for example, 2 raised to the 7th power is 128, so 2 to the 7th is 128. Works also as a square root in a way. Fractional powers are roots, so 9 to the 0.5 or 1/2 power is the square root of 9, which is 3. Sine and tangent are further important trigonometric functions where their argument is in radians as opposed to degrees, and the square root function computes the square root, such as the square root of 900 is 30. There are also two important static constants, pi and e, that are often used. We refer them as math.pi and math.e. E is the base of the natural logarithm. These are declared in the math class as public and const. Public means that other classes can use them, and const makes them constant, so their value cannot be changed after a constant is declared. So for obvious reasons we are not allowed to change the value of pi or e from their actual correct mathematical values. because they are static, we refer to them using the name of the class math and the member access operators. So as shown here, math.py and math.e. Since they are static, there is no need for an instance of the math class. When a variable is a static variable in a class, then all instances, all objects of that class share one copy of the class's static variable. This means that any object has access to the same variable that belongs to the whole class, not to individual objects. And any object can change it, but when an object changes it, it changes it for all other instances as well, unless of course it's constant, in which case no object can change it. The static variables and instance variables together are the fields of a class. An example of a static variable that is not a constant, that frequently used, is an instance counter. So if within a class we want to know how many objects have been created of that particular class while we are in the middle of running a program, one way to do that is to have a static variable that is always incremented by 1 when a new object is created, and always decremented by 1 when an object is goes out of scope and gets destroyed, and as a result the value of the static variable is always the number of objects that are currently in existence. It's a little bit like a factory keeping the number of, like a car factory keeping track of the number of cars that have been produced in that factory. When a constant is declared in a class but not inside a method, then it is implicitly static, and therefore the static keyword should not be used in front of it, because that would be a compile error. We have seen the main methods many times, and we know that it's a static method. The reason why it's static, because main is used as the entry point of a program, and by being static, the execution of the main method and thereby the entire application is possible without having to create an instance of the class. Main methods usually have command line arguments, which is a list of strings. It's actually an array of strings that are passed to the application, and generally they are type separated by spaces on the command line when we run the application from a command window. The actual command line argument is an array of strings. It's called args, that's the name of it, and the main method is always public. The public keyword might be omitted, and its default return type is void, so it doesn't return any information. However, it can be changed to type int, and the purpose of that is that it enables main to return an error code. And only one main method can be declared in a class. Error codes typically are set to 0, so it's return 0 indicates successful execution of the application, and a value different than 1 indicates an actual error code that can be various conditions that something went wrong. Every class can have a main method. However, we have to specify which one is the one that provides the entry point for the entire application, and that can be selected in the project tab properties, and then we have to select the startup object from a list box. An application we are going to look at is Maximum Finder, which calculates and returns the largest of 3 numbers. There will be a user-defined method maximum in it, which determines and returns the largest of 3 double valued numbers, and it will be public, so it can be called from other classes. It will be static and thereby allows the main method to call it directly without creating an instance, because static methods of a class can call each other directly. Other classes have to specify the class name before using maximum. Here is the code. So the class is maximum finder and the main method is public and static. Void is its default return type and has the arg string array as its command line arguments. We read in 3 double numbers by read line, console read lines, and each of them have to be converted to double. The 3 numbers are stored in 3 variables, number 1, 2, 3, and the largest of them determined by calling the maximum user-defined method and passing in the 3 formal parameters, the 3 actual parameters, number 1, 2, 3, and then we write out this maximum. Here is the actual method maximum, which is public static, return type double, and takes 3 double argument x, y, z are the formal parameters. It's static so that main can directly call it. Within the method we initially choose the first passed in argument x as our candidate for a maximum value. It may or may not be x, but we compare it with y. If y is less than or equal to x, nothing changes, but if y is larger, then we change the maximum value as our candidate for a maximum to the value of y, otherwise we don't change it. And similarly we compare it to z, and if z is less than or equal, there's no change, otherwise if z is larger, then we set the maximum value to the z. After these 2 ifs, the correct maximum value is stored that we return. And we can see some sample rounds, so 3 numbers in reverse order, and then selects the correct maximum, in a different order, and yet another order, and a really large number. So to write this program in Visual Studio, we start the class maximum finder, and what it does, it obtains 3 floating point, actually double, I would say that, see double values and determine the maximum, like that. So within the main method, we start by prompting the user for an input, so prompt for and input 3 double values. So the prompt is actually console. It will be a write line, and the prompt message is enter 3 floating point values, comma, new line, and we are not done yet, so we have to continue with concatenation. Pressing and single quote within the double quote enter after each one, colon space. So that's where we are done, end of the prompt. And now comes the actual input. So double number 1 equals, we have to convert it to double, and to read it we use a console read line, And then we can repeat this for the other two. One quick way is to simply copy and paste the instruction 2 more times, and all we have to modify is the name of the variables number 2 and 3. Maybe want to insert some spaces for better readability, like that. And that's the end of the input. So now we are ready to determine the maximum value, and that will be stored in a variable called result, also double, and we call our method, not written yet, maximum, not maximum finder, but just maximum, and number 1, number 2, and number 3. And the maximum is underlined because it's not written there yet. So once we know that, we are ready to display the maximum value. So it will be a console.writeLine, and we say maximum is colon space and concatenate plus result. That's the end of the display. With that, we completed the main method. What's missing now is the maximum method itself. So we write that. So we comment on its purpose. So returns the maximum of its 3 double parameters. So it will be public, static, and return time double. Its name is maximum, and it will take double x, double y, and double z as its 3 formal parameters. Then comes the body of the method, layout, and good to comment out. So end method maximum, and we are ready to write it. So we have a double maximum value equals x, and maybe comment there that says that assume x is the largest to start. And we have at this point an error. Maximum is underlined because we haven't returned a value yet. It will go away when we return the value. Then the first if determines whether y is greater than maximum value. So if y is greater than maximum value, if that's true, then we reassign maximum value to be y, otherwise it stays x. And we need a second if, so determine whether z is greater than maximum value. So if this time z is greater than maximum value, in that case we again change maximum value to z, otherwise remains unchanged. So once these two ifs are performed, maximum value should have the correct value, and therefore we return maximum value at this point. That also takes the underline from maximum, because we completed the code and we are also returning a value from it properly. So that's our code. We are ready to compile and run to see if everything is correct. So we save it all and let's build it. Generally, I recommend rebuilding it, especially for complex projects that consist of multiple files, which is not the case here. And with Ctrl F5 we can run it. So it asks for inputs, so maybe 2.22, 3.33 and 1.11, and the maximum is okay, I mistyped 2.33, so that's what it returns. So let me run it again and type the what we plan to do, namely 2.22 and then 3.33 and 1.11, and the maximum is 3.33 as planned. We can try in a different order, so maybe this time we start with the largest and it still returns the maximum correctly, and maybe try a case when the largest is the last one. So oops, 2.22, 1.11, and the last time to write some really large number, and then that will be the return value. So again, we use the static, created and used the static method passed in 3 parameters that main can call directly, because static methods can call each other. There's no need to create an instance of a class to use this. So that was our application to determine the largest of 3 numbers. When a method has more than one parameter, they are entered as a comma separated list, like in our case number 1, number 2, number 3 were. And the required parameters, when we write the method declaration are called formal parameters, as opposed to when we are calling the method, what we are passing in are the actual parameters. And the arguments have to be consistent with the corresponding formal parameters. So in our case it wasn't too hard because all 3 were doubles, but if it had been a double followed by an int followed by a string, then we have to pass them in that order, a double followed by an int followed by a string. Otherwise we get a compile error. When a control returns from a method, that is, a method goes out of scope, its parameters or its local variables are no longer accessible in memory. So neither the passed parameters nor the local variables of the method are no longer accessible. They are released from memory, and methods can return at most one value. If for some reason we need to return a lot of information from a single method, then there are several ways to do that. If they are all the same, they can be put into an array. If they are different, they can be put in a list, or we can create an object that contains in various fields the information we need to return. But there will be only one actual return value. However, it can be complex. It can be a collection or it can be an object. Generally speaking, variables should be fields of a class if they are required for using more than one method, so their value needs to be passed between methods, or the application needs to save their values between calls to the class's methods. Otherwise, variables should be local variables within the methods. If it's used in a single method and they are don't need to be saved, then they should be local and should not be fields. In other words, should not be class level instance variables or constants. You know that when several parameters are of the same type, we don't write as float xy, we have to write float x, float y. So that would be a syntax error. The type is required for each parameter individually. An alternative way of writing the method maximum finder is, instead of writing those ifs ourselves and calculating the maximum ourselves, we can use the max method of the math class. Note, however, that the method's max method return the larger of only two numbers. But that's not a problem if we want to return the max of three numbers. That means two calls to the math class, an example being on the screen. So we can call it between x, and then for the other two parameters we call max again, math.max yz. The second part will be evaluated first, that returns the larger of y and z, and then the alter max will be evaluated, that returns the larger of x and the larger of y and z, and therefore the largest of the three. And this could be generalized to more variables like 4, 5, and so on. In the next segment, we look at strings as passed in arguments, and also for string concatenation and its rules.